In-depth explanation. What is a circuit breaker pattern? The circuit breaker pattern is a design pattern used to handle failures gracefully in distributed systems. It prevents cascading failures by breaking the connection to a failing service, allowing the system to recover and maintain stability. The key idea is to monitor service calls and trip the circuit when failures exceed a defined threshold, thereby blocking further calls until the service is deemed healthy. Core concepts of circuit breaker pattern. 1. Closed state, normal operation. All requests pass through to the external service. Failures are monitored. 2. Open state. The circuit is tripped after failure thresholds are exceeded, e.g. failure rate or timeout. Requests are blocked and fallback logic is executed. This prevents further strain on the failing service. Half open state. After a cooldown period, a limited number of test requests are allowed. If the test requests succeed, the circuit transitions back to the closed state. If they fail, the circuit remains in the open state. 4. Fallback mechanism. Provides alternative responses when the circuit is open or failures occur. This can be a default response, cached data, or a simple error message. Apache Camel provides an abstraction for implementing the circuit breaker pattern, leveraging libraries like Resilience4j. Camel's circuit breaker is a route policy, or EIP, enterprise integration pattern that intercepts calls to an external service and applies circuit breaker logic. How it works under the hood. 1. Integration with Apache Camel routes. Camel allows defining circuit breakers in its routes using the circuit breaker DSL. The circuit breaker wraps service calls, e.g. HTTP calls, database queries, in a protected block, monitoring their success or failure. 2. Resilience4j library. Camel uses Resilience4j under the hood for circuit breaker management. Resilience4j provides the actual implementation of circuit breaker states, failure thresholds, timeouts, and recovery logic. 3. Monitoring failures. Camel monitors the responses from the wrapped service. Failures include exceptions, timeouts, or specific HTTP status codes, like 500. 4. Transition between states. The circuit starts in the closed state and allows all requests. If the failure rate crosses a defined threshold, e.g. 50% failures, the circuit transitions to open. After a defined wait duration, it enters the half-open state to test the service health. 5. Fallback handling. When the circuit is open, Camel executes fallback logic specified in the route. This fallback can include default responses or alternate workflows. 6. Configuration options. Thresholds. Define failure rates or request counts. Timeout. Configure request timeout durations. Recovery. Specify time to wait before transitioning from open to half open. How it is used with Spring Boot. 1. Camel routes in Spring Boot. Camel routes are defined as Spring Beans or annotated components in a Spring Boot application. The circuit breaker is added as part of these routes using the circuit breaker DSL. 2. Dependency injection. Spring Boot injects dependencies like producer template and camel context, simplifying route creation and management. Fallback logic. Fallback logic can leverage other Spring Boot beans or services. For example, fallback responses can come from a cache service managed by Spring. 4. Resilience4j integration. Camel uses Resilience4j's APIs and configuration properties. Resilience4j itself integrates well with Spring Boot via configuration properties, application.yml or application.properties. 5. Monitoring and metrics. Spring Boot integrates seamlessly with monitoring tools like Spring Actuator or external systems, e.g. Prometheus, New Relic. Metrics from the Camel circuit breaker, e.g. failure rates, state transitions, can be captured and visualized. Benefits of using Apache Camel Circuit Breaker with Spring Boot. 1. Graceful failure handling. Prevents cascading failures in distributed systems by stopping calls to unhealthy services. Allows applications to degrade gracefully with fallback mechanisms. 2. Integration simplicity. Camel integrates smoothly with Spring Boot, leveraging its dependency injection and lifecycle management. 3. Customizable and extensible. Fine-grained control over thresholds, timeouts, and recovery strategies. Extendable fallback logic leveraging Spring Beans and Camel components. 4. Decoupled architecture. Separates business logic from failure handling, improving code maintainability. Circuit breaker logic resides in Camel routes, making it reusable and centralized. 5. Observability. Metrics and state transitions are easy to monitor using Spring Boot's ecosystem. Integrates with tools like By leveraging Apache Camel and Spring Boot together, developers can implement robust circuit breaker logic while benefiting from Camel's routing capabilities and Spring Boot's ecosystem for development, monitoring, and deployment.